Hello friends, today we are going to learn IUPAC nomenclature of coordination compounds. There are several rules which we need to know before writing IUPAC names of coordination compounds. In this lecture, we will first learn all those rules and then we will do some exercise. We can summarize those rules under the following points. Point number 1, order of naming of ions. A coordination complex can be ionic or non-ionic. Ionic coordination complexes have two words name wherein cation is named first and then the anion. Non-ionic complexes have one word name. For example, AgNH3 twice Cl. This consists of cationic complex ion and anionic chloride ion. Since it is ionic, so its IUPAC name will be of two words. The first name will be of cation, which is complex ion, named as diamine silver first, and the second word will be anion, that is chloride. We will learn where the name diamine silver first came from in the later section of this lecture. Let's take the example of K4FeCN6. This is also an example of ionic coordination complex consisting of potassium as cation and complex ion as anion. So the first name of the complex will be potassium and the second will be hexacyanoferrate 2. Nickel tetracarbonyl. This is an example of non-ionic complex. It has one word IUPAC name, which is tetracarbonyl nickel 0. Point number 2, order of naming of ligands and metal. Ligands are named first and then the central metal. Ligands are written in alphabetical order irrespective of their charge. Point number 3, names of ligands. Names of negative ligands end in O. For example, F minus, Cl minus, Br minus, I minus, H minus, N3 minus, Cn minus, OH minus, NH2 minus, NH double minus, CH3COO minus, O double minus and O2 double minus. These are commonly known as fluoride, chloride, bromide, iodide, hydride, azide, cyanide, hydroxide, amide, imide, acetate, oxide and peroxide respectively. In complexes, these are respectively known as fluoro, chloro, bromo, iodo, hydrido, azido, cyano, hydroxo, amido, imido, acetato, oxo and peroxo. Let's have few more negative ligands. CO3 double minus, NO3 minus, C2O4 double minus, SO4 double minus, SH minus, S double minus, NO2 minus and NCS minus. These are commonly called as carbonate, nitrate, oxalate, sulfate, hydrosulfide, sulfide, nitrite and thiocyanate. In complexes, these are respectively known as carbonato, nitrato, oxalato, sulfato, mercapto and thio. Nitrite can be bonded to metal either through nitrogen or through oxygen. If it is linked through nitrogen, then it is called nitro or nitrito-N. And if it is linked through oxygen, then it is called nitrito or nitrito-O. Similarly, thiocyanate can link to metal either through sulfur or through nitrogen. If it is linked through sulfur, then it is called thiocyanato or thiocyanato-S. And If it is linked through nitrogen, then it is called isothiocyanato or thiocyanato N. Names of positive ligands end in em. For example, NO+, NO2+, and NH2, NH3+. These are commonly known as nitrosonium, nitronium, and hydrazinium respectively. In complexes too, these are called as nitrosonium, nitronium, and hydrazinium. Neutral ligands are named as such. For example, pyridine, triphenylphosphine, and ethylene diamine. However, there are few exceptions. For example, NH3, H2O, CO, and NO, which are named as amine, aqua, carbonyl, and nitrosyl respectively. Point number 4. Numerical prefixes to indicate the number of ligands. In the case of simple ligands like chloro, bromo, nitro, amine, aqua, etc., prefixes di, tri, tetra, penta, hexa, etc. are used to indicate their numbers. In the case of ligands already having di, tri, tetra, penta, hexa, etc. affixes in their names like ethylene diamine, triphenylphosphine, ethylene diamine tetraacetate, etc. Prefixes bis, tris, tetrakis, etc. are used to indicate their numbers. One thing we should remember is that after bis, tris, tetrakis, etc., ligand name is given in parentheses. For example, 2-ethylene diamine ligands will be written as bis-ethylene diamine, where ethylene diamine is in parentheses. If use of prefixes di, tri, tetra creates confusion, then in that case too, bis, tris, tetrakis are used even though the ligand doesn't have di, tri, tetra, etc. in its name. For example, to indicate 2-ethylamine ligands, it is written as bis-ethylamine, because if we write diethylamine, it will create a confusion whether there are 2 ethylamine ligands or 1 diethylamine ligand. So we don't use diethylamine to indicate 2 ligands of ethylamine. Similarly, to indicate 6-methyl isocyanide, we write hexakis methyl isocyanide and not hexamethyl isocyanide. Point number 5. Ending of names. In the case of anionic complexes, metal name ends in 8. Latin name of metals are used. For example, Pt, Cu, Fe, Ag, Au, and Sn are written as platinate, cuprate, ferrate, argentate, aurate, and estanate respectively. In the case of cationic or neutral complexes, metal name doesn't have any characteristic ending. Common names of metals are used. For example, Pt, Cu, Fe, Ag, Au, and Sn are written as platinum, copper, iron, silver, gold, and tin respectively. Point number 6. Oxidation state of central metal. Oxidation state of central metal is written in Roman numerals in parentheses at the end of the name of the complex without any space between the two. For example, K3FeCN6. The IUPAC name of this complex is potassium hexacyanoferrate. In this complex, oxidation state of iron is +3, that will be written in Roman numerals in parentheses at the end of the name of the complex without any space between the two. In the case of zero oxidation state, 0 is written in parentheses. For example, NiCO4. Its IUPAC name is written as tetracarbonyl nickel 0. In the case of negative oxidation state of the metal, minus is written before the Roman numeral in parentheses. For example, in NaCO4, the oxidation state of cobalt is -1. So the name is written as sodium tetracarbonyl cobaltate -1. Point number 7. Bridging ligands. Ligands which connect two metals are called bridging ligands. Greek letter mu is written before the name of bridging ligand to indicate bridging. Prefix mu is repeated before the name of each kind of bridging ligand. Prefix mu is connected to ligand name through a hyphen. Let's take the example of cobalt-based complex with two bridging ligands. In this complex, the two bridging ligands are amido and nitrito N. So, while writing IUPAC name of this complex, these ligands will be written in alphabetical order as mu amido, mu nitrito N. There are two tetraamine cobalt units with +3 oxidation state of cobalt. So, this part will be written as bis tetraamine cobalt 3rd. Since counterion is nitrate, so we will put the nitrate in the last to get complete IUPAC name of this complex. We can also write its name as mu amido mu nitrito N octaamine cobalt 3rd. Let's take the example of iron-based complex with bridging ligand. In this, there are two hydroxo groups that act as bridging ligand and two tetra-aqua iron units with +3 oxidation state of iron, and sulfate is the counterion. So we can write its name as di mu hydroxo bis tetra-aqua iron 3rd sulfate or di mu hydroxo octa aqua di-iron 3rd sulfate. Similarly, this palladium based complex with bridging chloride ligands can be named as di mu chloro bis chloro triphenylphosphine palladium 2 or di mu chloro dichloro bis triphenylphosphine dipalladium 2. This cobalt based anion can be named as mu hydroxo mu imido bis ethylene diamine cobalt 3 ion or mu hydroxo mu imido tetrakis ethylene diamine dicobalt 3 anion. Let's take the example of di-iron nonacarbonyl. Here there are 3 bridging carbonyl ligands and 2 tricarbonyl iron 0 units. So the complex name will be tri-mu-carbonyl bis tricarbonyl iron 0. Point number 8. Naming of complexes having metal-metal bond. The metal-metal bonds are indicated by italicized atomic symbols separated by a longer dash and are enclosed in parentheses placed after the name of the central atoms but before the parenthesis containing the ionic charge. For example, Re2Br8 double minus, whose structure is like this, is named as bis tetrabromorenate Re2. Since there are two ReBr4 units linked together via Re bond and the overall charge on the complex is -2. Similarly, Mn2CO10 represented like as with Mn bond is named as bis pentacarbonyl manganese Mn. Point number 9. Naming of geometrical isomers. Geometrical isomers are named as cis or trans. Name starts with italic cis or trans followed by a hyphen and then usual IUPAC name of the complex. For example, cisplatin and transplatin. Cisplatin is named as cis diamine dichloroplatinum 2 and transplatin is named as trans diamine dichloroplatinum 2. Point number 10. Naming of optical isomers. Dextro or levorotatory optically active compounds are designated by plus and minus or D and L respectively. For example, dextrorotatory K3IR C2O4 thrice can be named as potassium plus trioxalato-iridate third, or it can also be named as potassium D trioxalato-iridate third. Now we will do some exercise. Suppose we have to find IUPAC name of CONH36Cl3. For this, we will follow these steps. Find out whether the complex is anionic, cationic or neutral. This complex is cationic because the counter-ion outside the bracket is anion. So, IUPAC name will have two words. Complex ion being cation will be named first and then the counter-ion. And common name of the metal will be used, which is cobalt in this case. Find the oxidation state of the metal. Suppose the oxidation state of cobalt in this complex is X. NH3 has 0 charge while chloride has -1. So we can write X plus 6 into 0 plus 3 into -1 is equal to 0, or X minus 3 is equal to 0, or X is equal to plus 3. Ligands. There are 6 NH3 ligands. So the IUPAC name of this complex will be hexaamine cobalt 3 chloride. Let's take the example of this palladium based complex. Find out whether the complex is anionic, cationic or neutral. This is a neutral complex, so it will have single word name. Common name of the metal will be used, which is palladium in this case. Oxidation state of metal is 0. Ligands. There are 4 triphenylphosphine ligands. Since ligand name has word tri, so tetrakis will be used to indicate its number. So the IUPAC name of this compound will be tetrakis triphenylphosphine palladium 0. K3FeCN5NO. Find out whether the complex is anionic, cationic or neutral. This is an anionic complex because the counter-ion outside the bracket is potassium, which is a cation. So it will have 2 words name. Counter-ion will be named first and then the complex ion. Latin name of metal ending in 8 will be used, which is ferrate in this case. Oxidation number of metal is +2. Ligands. There are 5 cyano and 1 nitric oxide, which is called nitrosyl in the complex. So the IUPAC name will be potassium pentacyano-nitrosyl ferrate 2. Now let's take an interesting example of PTNH34 PTCl4. In this case too, we will first see whether the complex is anionic, cationic or neutral. In this case, it is cationic and anionic both. This part with +2 charge acts as a cation, and this one with -2 charge acts as anion. So the complex name will be of two words. Cationic unit will be first and then anionic. Common name of the metal will be used in cation, which is platinum. Latin name of the metal with ending in 8 will be used in anionic unit, which is platinum in this case. Oxidation state of the metal is +2. Ligands, there are 4 amine and 4 chloroligands. So the IUPAC name of this compound will be tetraamine platinum 2, tetrachloroplatinate 2. That's all in this video. Please subscribe my channel and press the bell icon if you like this video. Thank you very much.